Welcome to my channel. So in this video I will be solving this immediately concluded practical questions. I will also have my own review after the solving. You're looking at the screen now, you are seeing the instructions. So first of all, we need to make our table, which I taught us how to make my live stream. So the image is not straight, so my table will not rhyme with the conformity of the picture I took. Or let me try as usual. Okay, remember not to cancel your table. You're advised to make a table of 3, 4 rows and 5 columns. So here is my reading. Here is final, all in cm cube. And then, so that average volume of A, let me finish everything here. A bracket VA is equal to first plus second plus third over 3, which is going to be 25.20 plus 25.1 plus 25.20 divided by 3. At the end we have 25.16, if I'm not mistaken, because this will give us 75.5 in total divided by 3. So 75.5 divided by 3 will be from the 75.5 divided by 3 is 25.16. So we have, okay, there is still enough space here. So we have our average is 25.17 on the approximate cm cube answer. So to go to the next page, we omitted volume of pipette used 25.00 cm cube. Present a network. Over here is the continuation, which says from your results and the information provided. So I'll still go back and get that information provided in the other part. This information is that A is 0.825 gram in 250 HCl, 0.825 gram in 250 for HCl, and the other one is 4.0 gram in 250 cm cube of sodium hydrogen thiazocarbonate 4, but this is impure, so the carbonate is impure. So we can now proceed from my results, which is 25.17. the concentration of A in mole per dm cube. A has been provided to be, A contains 0.825 grams in 250 cm cube. First, we find the mass concentration, like I told you in my live stream. If not in 1000, find out the one in 1000. So 250 is not 1000, because concentrations are measured in 1000 cm cube will now contain X. Cross multiply we have that 250x is equal to 0.825 times 1000, so that x, we divide both sides by 250, so cancel, so that x alone will now be, from the calculator department, we can cancel a bit, so that 5 by itself is 1, by 100 is 4, 0.825 times 4 will now give us our final answer. We are not final answer actually. 0.825 times 4, 0.825 times 4 is 3.30. okay, 3.30. So our x is 3.30 gram per dm cube, but we have told to find the concentration in mole per dm cube. We now say mole per dm cube is equal to gram per dm cube all over gram per mole. Interpreting this, it means mass concentration, molarity is equal to mass concentration over molar mass. Now, what is the molar mass of HCl? That is the gram per mole of HCl. Hydrogen is given as 1, chlorine is 35.5, so that we have 36.5 gram per mole. Then the mass concentration is already gotten as 3.3. Therefore, our mole per dm cube is equal to 0.825 divided by 36.5. From the calculator department, we have 3.30 divided by 30. Did I use times instead of divide? Divide by 36.5 gives us 0.094. Okay, three significant figures. 0.0941, maybe. I wouldn't know if significant figure is the same thing as in mathematics. Okay, what mole per dm cube, our final answer for this question. So we move to the next. Says concentration of solution B in mole per dm cube. Solution B is 4 grams in 250, but that 4 grams is impure, so we don't know the mass concentration of the pure. Therefore, this place we are going to use CaVa all over CbVb equals Na over Nb. We are looking for Cb. Remember to make what we are looking for subject to the formula. Cb here is equal to CaVa Nb divided by Vb Na. And I hope the equation of reaction is still 1:1. I didn't look well, but let me assume it is. So our concentration in mole per dm cube of B is the concentration of acid in mole per dm cube, which is 0.0941 times what? 25.17 times 1 divided by 25 is the volume of the pipette I use as I shown on my table, times 1. And the answer here definitely is going to give me the same thing as 0.09 almost, because 25.17 and 25 is just infinitesimal. But let's get the exact value. Okay, 0.0941 times 25.17, if I'm correct, then divide by 25 itself, 0.0902, 0.09102, 0.09102, giving us 0.09102 to obey 3 significant figure, I wouldn't know. Then mole per what? dm cube. Remember, wrong units, you will lose the score. Okay, we go to question II. The II say concentration of solution B in gram per dm cube. We are now going to convert mole per dm cube to gram per dm cube. So we will still use the formula which says that mole per dm cube is equal to gram per dm cube all over gram per mole. And our mole per dm cube is 0.0, I can't recall exactly, let me look it up. Okay, 0.09102. 0.09102. 0.09102 is equal to gram per dm cube divided by the molar mass of sodium carbonate. Let me show my work. Molar mass of NaHCO3 is equal to 84. How do we get that? Sodium is 23, hydrogen is 1, carbon is 12, oxygen is 16 times 3. If you sum this, you are going to get this. Divide by 84, such that what happens next? Our gram per dm cube will now be equal to 0.09102 times 84, right? So the gram per dm cube will now be equal to, we just say times 84, gives us 7.64 or 7.65, yeah, 7.65 gram per dm cube. This is our answer. We move straight to IV. Okay. Question IV says the percentage purity of sodium hydrogen thiazocarbonate 4. We have gotten 7.65, okay, as the pure sample, 7.65. So percentage purity is equal to mass concentration, which is the mass of pure, of course, divided by mass of what? Impure sample. I advise you put sample there, because when you say mass of impure, it looks as the mass of impurity itself times 100 over 1. So what's the mass conc? Mass concentration is also equal to mass of pure sample, because the part that takes part in neutralization is the pure sample of the base. The base is only base that will react with the acid. Okay, mass concentration is also mass of pure sample. It's just like if you mix sand and iron filings. When you bring a magnet, the magnet will just pick the iron filings and leave the sand behind. So the impurity is just like a sand, which the pure sample, which is a base, will only react to the acid. So out of the whole thing they provided, we are looking at the pure sample as 7.65 from the approximate 7.65 gram mass of pure. Then the total mass of impure sample provided is going to be 8, because they say it's not 8, please. They say that 4 is in 250. So mass of impure what? Sample in gram per dm cube will now be, since they told us that 250 cm cube contained 4.0 gram of the impure, 1000. Why are we doing this? To make sure that this unit, like, because this 7.65 gram is in dm cube, but this 4 gram is in 250. So don't use 7. If you do it safe, you find out that mass of pure is greater than the total mass, which is wrong. So you must find out the one in 1000 so that it will rhyme. Automatically x, you cross multiply, so that x will be 16 grams. We have 250 x equal to 4 times 1000, such that x is equal to 4000 divided by 250, which gives us 16. If I'm correct, yes I am. So 16 gram per dm cube for mass of impure air sample. Therefore, percentage purity, we have gotten everything we want, should now be 7.65 gram, which is the mass of pure, all over 16 grams times 100 over 1. So from the calculator department, we have that 7.65 times 16, okay, 7.65, which is 765 divided by 16, 765 divided by 16, 765 divided by 16 is equal to 47.8%. 47.8%. So percentage purity here is 47.8%. Our answer. We now go to question. The next one should be the salt analysis. That's the qualitative analysis anyway. I believe my solvings are correct. They are, of course. Okay, here is the salt analysis. They gave us this information. C is a mixture of two substances. Perform the following exercise. Put all of C into a beaker and then add as usual, as their normal grammar. So what you are required to do here is to make your table and number correctly. Maybe test right. So the A part of it simply says C plus 10 mil, C plus 10 cm cube distilled water plus stir plus litmus. Okay, observation: C dissolves to form a blue solution, or you say a light blue solution turned full stop, or you say which turned, you might continue, solution turned red, my turned blue litmus paper red. Don't say damp here. Some think that damp is the correct thing. No, damp or moist. No, you don't moist while testing a solution that is aqueous. It already have that water. So what are you damping there? It's already water. It's just like going to water. Say, before I enter this water, let me first of all wet myself. How? But you are moving into water. Do you understand that? So it's ignorance and a lack of or let me use the word poor understanding. Ignorance might be too harsh. Poor understanding. All right, make a neat table. Doesn't cost anything. So what should be your inference? You say C is what? Soluble. Solution C is acidic. So each test, when you finish up, you do what? Try to rule. Then the B, I said divide into 4 portions. So the first portion, you add sodium hydroxide in drops. So we have first portion of solution C, or you say C aqueous. You can say C aqueous plus NaOH aqueous in drops plus excess. Observation: I don't know what I want us to write here. Light blue gelatinous precipitate in excess, if you want to report the rating, or this is Africa, sha. If you want to report the rating, the gelatinous precipitate dissolved in excess sodium hydroxide, because there is a mixture of glucose. And so for me, I will base on the fact of observable thing. So which did what? But they were expecting you to say which remained insoluble in excess, so that you cannot say copper 2 likely or present, and you now go to ammonia and confirm copper 2. That is it. This is what I did when I did not. I also assumed this in my brain until I do the test and see that it is not true. So I don't know whether WAEC, and every time Africa keep moving far away from science, and it pains me a lot. How long? Imagine this pattern of my grandfather will wake up from grave and still know that what we are doing is titration sort analysis in the same format. Nothing has changed. Nothing ever is even planning to change. If an African man invented a car, by now we will still be driving Carbenzi's first car, which looks more like a bicycle. Innovation is poor. And what causes this? They hire people, and immediately an average African man makes money, his sense is gone. He start living into it, and now start intimidating others with professor, doctor, especially with titles left and right. Do you get this thing now? They don't go down again, because this problem now with sodium dioxide, I encountered it honestly with my theoretical analysis, but in practical it's not true. It dissolves. Why is it dissolving? I don't know, and I'm sure I'm not the only one that encountered this. If you watch my live stream, when it dissolved, I was shocked. I have to make new sodium dioxide even after test whether what I have is sodium dioxide, and it still dissolves in excess. Then after which it's now start giving a greenish precipitate that start turning even brick red or orange red, like detecting glucose. So I don't know. But here, they expect you to write which persists in excess, which dissolves. But I'm writing what is practical. Science is bigger than WAEC. Science is bigger than that certificate or whatever I will have to report reality, okay? I must not report to suit you. It is you, maybe, or any other person that don't like science will report all those things. And we are keeping quiet. WAEC is deteriorating, and we think they are improving. Just see what JAM did and scored people anyhow. We now say that this is how WAEC will keep it up. Especially in chemistry, every year we notice this thing. Why are they doing it? You cannot do experiment and give it to children to do. How? You just stay and absorb theoretical things. That is not it. So which dissolves in excess to form a deep blue solution. Other ones are longer story, which on standing turned greenish yellow precipitates, which started turning even reddish brown. So for inference here, I don't know. I'm not saying you should write, but you should not write at all. But in exam, if you are a student, I will advise you write for them light blue gelatinous precipitate dissolves insoluble in excess, please, so that they will expect you to write Cu2 plus present. It doesn't. This is forgery, so I'm not writing it here for you. I'm trying to explain why it started turning a bit, because at long run it turned brick red, confirming glucose. Because I produce Ferlin solution B and also A, I discovered that a chelating agent is needed. But why did it even dissolve for the first time to form a deep blue solution? I don't know, but I'm explaining possibility of what gives that brick red on standing. Maybe the alkaline medium needed has been provided by the sodium dioxide, and the copper 2 ion now reduced to copper 1, which is down. That's responsible for that color. Okay, so this is for science, not really for work. Okay,
if na science equipment or reagents you define, no dull at all. Na Her Majesty easy world science sure pass, na sure plug. Buy from scientists wey sabi road o. Na me, and I dey guide you proper. No go buy anyhow, come dey call me make I explain why your experiment no dey give better result o. Na better reagent and better equipment dey give better result o. I be say you wan turn your chicken to elephant. Na you sabi o. Okay, I even dey run 15% discount plus quick and smooth delivery. My guy, I no go fall your hand. I need your patronage, Biko.
Guys, Her Majesty took away my fear I had in chemistry and biology. You have to join the easy ones. My name is Victor Modia, a student in Italy. Anywhere you are, you can join us. Join the easy one. Be a subscriber. Bye. Thank me later.
okay, over here is the full report, I concluded it over this page. Okay, so second portion, third portion. So this is it for the salt analysis. We go to question 3. Question number 3. It says a tetraoxosulfate salt P was heated with sodium hydroxide solution. A gas R was evolved which turned red litmus paper blue. From the information provided, I commend this question. It's very nice. It's well crafted question and shows a lot of sense there. It looks simple but not too simple. So when a child hears tetraoxosulfate 6, if you are not so rooted, if you don't listen to your teacher while we are doing tests for cations, especially tests for ammonium ion, whereby you need to add sodium hydroxide. If you add sodium hydroxide solution to any salt or any salt and heat or warm, and it liberates colorless, odorless gas. Is it odorless? No, colorless gas with a choking, irritating smell. That confirms ammonium salt. So even though they now distracted students by using tetraoxosulfate 6, so but what we call a child that is serious back is the action on litmus. That's where they made the question at least a bit easier, okay? And they called what it means. I commend them. I like this type of question. It's not easy. It's well crafted from... I just love it because if you say ammonium sulfate or ammonium, a child will immediately, this is all about testing if students really can apply the knowledge they have learned. That's the synthesis, being able to take this knowledge to the other field or being able to have a very nice critical thinking, okay? So this is ammonium sulfate. That is the salt. It's not actually test for sulfate. Rather, what they stated here is test for ammonium salt. But it's only a clever student that will understand what they mean there. So WAEC, touche, congrats. I love this question. Very nice. Okay, then students, sorry if the question pulled you. That's only those that are not doing my practice. I know if you are doing my practice, you use either your teacher will use AI. But that won't help us at all. Let's say no to examination malpractice. And WAEC should also say no to more important certificate than science. Science is over everything. Please, if you are close to these people, they should stop bringing in sample that they did not analyze. They should stop assuming science in their head. Let them do it. We call it practical. I don't know, because if you have the highest lawyer, highest barrister, you might talk down on me and say they purposely put it to know if the students are doing it. Don't say that thing. Because with that of sodium hydroxide and glucose mixed with copper 2 sulfate, what would they report as their inference? Light blue gelatinous, which dissolves to form a deep blue, and on standing, turn greenish and start... Oh boy. I don't know you. Whatever you turn around is your business, but I'm here standing in for science. It doesn't make any sense. You don't. I was a victim. I assumed that same thing until I did it. I was shocked. So I know how they feel. Don't feel that you know science until you do it. Nobody is above this thing. So in Africa, you see people that are above that thing. Say, come on, we have finished it. Is it today that we started titration? Is it today that we started salt analysis? Let me not go there. Africa, God bless you. We will move on. One day we'll wake up from our slumber. A gas R. So I've mentioned that the gas is the salt is ammonium salt, whether it's sulfate or not. Since they have mentioned soda dioxide and the ammonia gas, the only common alkaline gas we have is the ammonia gas. Okay, it's alkaline because it turned red litmus paper blue. So R is nothing but ammonia gas. Okay, R is ammonia gas. You can write formula. It's accepted. Then give the confirmatory test for R. You can say it forms white dense fumes with what? Forms white dense fumes with glass rod dipped in HCl. I think this is the dipped in either dilute HCl or conc HCl, anyone to do it. Or you say it turns. Okay, they say confirmatory test again, and they mentioned it there. You can say the gas has a choking smell. You say has a choking smell and is colorless. It turns colorless with choking smell, turns moist. This is where you put moist or damp. You can put the other one, colorless, choking. It's a colorless gas with a choking smell, which will turn what? Which turns damp red litmus paper. But they have mentioned it there, red litmus paper blue. but I advise you say that first one. They write the formula of P, that is the ammonium sulfate, which is NH4 bracket 2SO4 ammonium tetraoxosulfate 6. Then they say name P. Imagine it's not easy, sure. Ammonium tetraoxosulfate 6, and that wraps it up for this immediately concluded practical chemistry. Thank you for watching. Please subscribe and then share this video. Subscribe and share, please. Share and give me your own contribution. Much love. Stay majestic.